The design team have reviewed the digital prototype of the robot that I sent them and have identified two problems. The first is between the battery holder and the flat bearing, so there's some interference there. Just going to go out and measure that. So from the flat surface on the bearing to the top surface on the battery holder, and that's 0.2 inches. The second problem is between the cap screw and the battery itself. The counterbore hole is not deep enough. So let's go in and do an analysis on that, check for interference. Select the cap screw as set number 1, and then select the battery as set number 2. And we can see that there is interference. In fact, you can see it quite clearly as I zoom in, and that's the top of the cap screw. So we'll need to increase the depth of the counterbore hole. We now have the battery holder part, and both of the modifications are around those counterbore holes. In the drawing, I can see that the first dimension was 1.25. I'm going to increase that to 1.5, and the depth of the counterbore from 0.06 to 0.09. I could use direct editing. I could right-click in the browser on the hole feature and either edit the sketch or edit the feature. In this case, I'm going to click on the feature itself and then select the feature icon. The dialog box appears, and all I have to do is key in the new value, 0.09, and the depth of the hole now is increased. Same workflow. This time select the sketch icon and change from 1.25 to 1.5. And when I finish sketch, you'll see the two holes are going to move backwards. There they go, so the modification has happened. I'm going to save that file, and then go back into the drawing, and you'll notice the dimensions have updated. So really, once you create the first drawing, everything else will update if you make changes in the model. Back in the assembly, let's see if that's changed. So let's check the first one, which was the interference between the bearing and the battery holder. Doesn't look like it has. What I have to do is update that. Once I do my update, then it's correct. And we can see that gap in there, so that's good. We have some clearance. Zoom in a little bit so we can see it better. There it is. So that new dimension of 1.5 is good. Let's check out the cap screw and the battery. Check for interference. Cap screw for set 1, and the battery is going to be set 2. Of course, this time there should be no interference. Select the battery, click OK, and that's good. There's no interference. With the modifications to the part completed, I'm now going to export the file to a different CAD format. I'm going to change that to STL, stereolithography. Check the options. My units are inches, which are correct. You may wish to change that to millimeters. My resolution, I'll leave it medium, and all of the other options are good. So I'm going to save that and send it over to the team to create a 3D print. The robot design team have created a 3D print of the new battery holder design. They started by assembling it in this horizontal position, as you can see, and in this case it worked very well. When the design team assembled the battery holder in the vertical position, they were a little bit concerned that the battery wasn't quite as secure as they would like. So we're going to look at a design change to the battery clips. This will take into consideration any variations in the size of the battery, but at the same time ensure that we can snap the battery in and out easily during competition. In conclusion, we created a digital prototype in Autodesk Inventor and then sent that model to a 3D printer. By doing this, we were able to create a good design for a new battery holder.